Hey guys, welcome back. Next, we are going to discuss breadth first search traversal. BFS is completely different way to traverse the vertices of graph. In this, we start from a vertex, let's call it a source, and we traverse all the nodes in current level first. And then we move to the next level. Like here, the source vertex is 8. We start from 8 and then we move to the next level to traverse 1, 2, and 9. And then to the next level, which is having 3, 4, 5, then 6, 7, and then finally 10 and 11. So that's basically level order traversal. So BFS is also called level order traversal. Now to figure out which nodes are in its current level, we use a queue as auxiliary data structure. What we do, we put the source in this queue, and when we visit the source, we remove it from the queue and put all of its adjacent nodes in the queue. This process continues, that is, we keep on removing the items from the queue in FIFO order until queue gets empty. Here, one is processed as its adjacent 2, 3, and 4 are visited and inserted in the queue. Now we process the topmost node 2 and we put all of its adjacent unvisited nodes, which are 5 and 6, in the queue. Then we process 3. 6 is already visited, so we only put 7 in the queue. And this continues, we keep processing the topmost node in the queue and keep adding their adjacent nodes in the queue if they are not visited until the queue gets empty. So at last, all the vertices will get processed and we get the breadth first search traversal for the graph. That's the whole idea of BFS. We process vertices level by level. Now let's check its pseudocode. We start with a given vertex. We add this vertex in the queue and mark it visited. Then we start dequeuing the nodes from the front of the queue and look for its adjacent vertices. We trade through its adjacent vertices and add them in the queue if they're not already visited, and we mark them visited. When we traverse all of its adjacent nodes, we print the current vertex. And now this will be repeated until each vertex gets visited, that is, until the queue gets empty. So that's all about the logic. Now let's implement it in code.